So if you want to solve the Laplace equation inside a disk, given some boundary conditions on the edge, then you want to transform this to the upper half plane, W plane. And a useful transformation to remember to do this is W equals I times 1 minus, so it's obviously a bilinear transformation. So we can check that this works just by looking what happens to z equals 1, z equals I, and z equals minus 1. Okay, so as we go around here, the thing on the left is the region we want. Okay, so z equals 1 gets transformed to 0. So this point gets transformed to 0. Z equals I, that's a bit we need to do a bit more work for. So that's 1 minus I divided by 1 plus I. So writing that in polar form, that's e to the minus I pi by 4 times root 2 divided by e to the plus I by 4 times root 2, and then times I. So that's going to give e to the minus I pi by 2, which is minus I, which is 1. So this gets mapped to 1, and minus 1 obviously gets mapped to the point in infinity. So as we move around here, the bit we want is on the left, and sure enough, as we move from point to point, the bit we want is on the left. So this is indeed the transformation we need when we're solving the Laplace equation inside a disk. Then we transform the boundary, then we see how the boundary maps. This is also useful to remember. So if we've got a sort of constant potential here from 1 to I, then that constant potential here will get mapped to this region here, and so on.